All right, so my name is Maxime. I'm a cloud advocate at Microsoft. Basically, I'm paid to do conferences, and I'm paid to write fun code. And I'm basically paid to help, which is fun. I don't have any sales numbers. So I have no pressure, and I love talking about those. My favorite piece of technology right now is durable functions. And since this is Serverless Boston, you know what? Let's talk about it. So who uses Azure Functions here today? Few hands up. I love that. It's cool. I was at Serverless Toronto. I had the same kind of crew. It's cool. So basically, we're going to resume a little bit what Azure Function is, but it's basically an overview of what a serverless is. I'm pretty sure all of you know. So we basically have events, and serverless code basically answers that. So whether it's timers, HTTP, events, or whatever services you want to be hooking from, the functions is going to hook itself to those different events. Of course, now you want to have some code to run against those events. So whether it's C#, F#, or JavaScript, or Java, or whatever the new language trend is today, you want to have code run against this. And finally, at some point, you want some kind of outputs. So most functions will generate an output, not necessarily when you call them back. Things you would see normally in an API, they would return the result directly into the response. But sometimes the output is about putting a file somewhere. It's about storing the result of the execution, of the processing somewhere. So, but it's always the same pattern. There's events, there's code, and there's outputs. All right, and what do we support right now? Well, those are the big ones. So we support C#, JavaScript, and F#. They're all in GA. Java is still in preview, I think. We do have experimental languages that are always fun. If you want to try them out, or you want to know if your language is supported, we have this little link here. But personally, I'm a fan of Google. Yeah, not Bing. I'm not one of those Bing guys. So you just do Azure Functions, supported languages, and you press Enter in Google, and the first link at the top is it. It's our docs. And you will have everything from what is GA, what is preview, what is experimental. Because we have those experimental languages here. What is that? What does experimental mean to your business? Because if you're not going to get any support, it would be nice to know. All right. I just realized that this is white, like really white and really bright. So there's a lot of functions, and there's a lot of triggers. So those are the keywords that we're going to work with today, is the function triggers and the bindings that we have to the different services. So the triggers, as you can see here, this is just a small overview because we're adding them, I think, every year, but on a little bit faster schedule, but there's new ones that we can create. So the classic one that most platforms will support are normally on schedule, so timers, HTTP, and those are triggers. This will be, when does my function start? And then we have things like blob storage that has input. And that basically can mean, well, I want to have something imported from my storage to be in part of this context of this function when it runs. And then output means that when you return the function, you can return a stream. So basically, for the blob storage would mean that you would be saving the file to storage. So those kind of behaviors are supported like through all those different elements here. We have events, we have queues, we have SQL tables, and Twilio SMS text, and Excel tables. Yeah, Excel table is fun. So all of those allows you to run your serverless code. But enough about Azure Functions, right? I mean, we all know you're all running it already. Everything's fun. You're enjoying your experience, or at least after seeing durable functions, you will want to use them. I sure hope so, because I find them super cool. So what is durable functions, right? Before we dig too deep inside of it, we know that we're dealing with serverless workflows, because that's the title of the track. So let's get to that. But before we go there, we need to understand a few concepts about durable functions before we move in a little bit closer to this amazing stuff that is the workflows. Durable functions introduce a few concepts, like activities and orchestrators. And there's a few things like bindings that we will cover a little bit, but there's also event sourcing. Anybody knows what event sourcing is? OK, we will walk through this a little bit down the line. But basically, it's about, if you know accounting, it's about keeping a ledger. And it's about keeping a ledger, but in this case, we're not keeping track of money. We're keeping track of execution. And event sourcing allows us to replay the execution through the event sourcing because we have a ledger of all the execution that is happening. So let's get to basics, like really basics. We have the concept of an activity functions. So we have this say hello functions that we're going to reuse in a few minutes. And that's simple, right? We say hello, and we have a return. And it could be written in any code. This one is in C#, but it could be in Node. It could be in no other languages because we don't support it yet. But those are the languages that we have. So who knows C#? OK, good. Java? Java is good? OK, you will understand this then. It's good. You want to try the other end? It's a good workout for both arms. So let's get to orchestrators. An activity is just that. It's running code. It's running business logics. And an orchestrator has a few different components here. We have a durable orchestration context. It's going to be called differently a little bit in Node, but basically that's the same thing. We're talking about a context. And this context has methods on it. And it will track the execution of your orchestrator. You will have an ID. You will have a whole bunch of different properties identifying your orchestrator at this point in time. And what you see here is we have a call activity async. And we have this component that say, well, call this previous function, that's the function, the activity that was called say hello, and give him the parameters Seattle or Amsterdam or whatever. But we have an await here, and we're going to say, well, like, you know what, call this, and when you're done, return to me. And we're chaining those functions together to return hello Seattle and hello Amsterdam. So that is the basic of an orchestrator. We're calling orchestrator call activities. Activities do the heavy lifting, and everyone is happy. End of presentation. Thank you. No, I'm joking. Let's get to a little bit more complex. So event sourcing. So we're talking about the local state in a pen-only execution history of actions. And that's exactly what I was saying earlier, is that we're just keeping a ledger of everything that is running. The orchestrator is in charge of doing that. The orchestrator functions will schedule work. It will not run the functions. The semantic here is important because it is a bad practice to call other functions from another functions because now you're having dependencies that are deeply linked between those two functions. Another thing that we know is that the orchestrator is going to run multiple times. So it will rebuild the state of where it's at. Because what if a function, an activity function, actually takes longer to run than the orchestrator takes longer, and the orchestrator has to wait? You don't want to be paying for those cycles anyway. So what does that give us? It gives us improved performance and scalability. It gives us eventual consistency. So if the whole process shuts down and restart, or if the machine that is running the process in the data center just blows up, basically we can just restart it as long as we have the data somewhere. What that also means with the event source, with the ledger, is we have this full audit trails of everything that's been running with your function. Every single input and output of your activities are logged, and we know exactly what happened and what went wrong. And we can basically rerun the same code with different parameters and see why does this one fail. So this is an animation-heavy slide, but basically it will allow you to understand a little bit of what's going on within the deeper inner working of durable functions. This is the most simplest functions I could muster, and it's basically a single activity that has the await keyword. Basically means, from the C# async point of view, I will wait for this until it's done. Here I yield back my thread. You can do whatever you want after that. But I will wait. So what do we do? First, the orchestrator is going to start from any kind of bindings or any kind of triggers, doesn't matter. We will start an orchestrator functions. It could be from an HTTP call, but it could also be from a new file uploaded to blob storage. So if you want to process things with an image, it's always possible. But in this scenario, we're going to have an orchestrator that's going to start. And then, on the right, what you're going to see is the events that are happening. So we see here that the orchestrator started and the execution started. Different concepts, but we'll understand them a little bit better in about 2 minutes. So it will initialize the list, we'll get to the outputs, and it will reach call activity async with those parameters. So the first thing it's going to do is going to look in the execution history and say, do we have anything from this orchestrator that called the sayHello function with those parameters? Do we have anything? And your execution history will return no results. So the orchestrator function at that point knows that this activity has not been run before. So what will happen is that we will schedule the task to run sayHello with the Amsterdam parameters to be run. And it's important here. We're talking about scheduling. So we're using queues. We're not talking about calling a function directly. We're not running multiple functions in parallel and in a thread-locking ways with crazy high-performance consideration here. We're just queuing up work to be done. And then the orchestrator, since it's going to have to wait, will need to yield back. So the orchestrator is going to complete at that point. The orchestrator is going to shut down. No other code is going to be run. It's going to wait. It's going to shut down. So the orchestrator is going to be completed, but the execution is still running. And then the activity will, at some point, unqueue the workload and say, well, here's the parameter I have, which is Amsterdam, and I will return sayHello. I will return hello Amsterdam. And that will be stored into your execution history. Once this is done, the orchestrator will notice that there's something that happened here, that the activity is going to have changed. So the orchestrator is going to start again. It's going to go through the exact same workflow than before. We're going to go back to the call activity async. And we're going to be like, hey, sayHello, Amsterdam. We have this somewhere? And the execution history will say, yes, that function executed before, and here's the result. And the output is automatically going to have this hello Amsterdam automatically stored within the list. And then we're going to return finally the outputs, and we're going to be completing the execution with hello Amsterdam. So this looks super complicated to do something super simple. But it is important, because the next part is going to be super interesting. So orchestrator completed, because now you can start to think about those things and start to create patterns out of them. So the first thing we saw with the await is called function chaining. So you're taking the context here and you're starting the first function. And maybe this function is going to return a result. Maybe you want it in the second function. So you want to do F1, but F2 takes the output from the first one, and you keep on going on like that. How would you synchronize, how would you do this work of running functions in a very specific sequence without creating a whole different architecture that you have to manage threads, you have to manage queues, and you have to manage all those events? And all of those are going to be called in sequence. But that's just because we're using await. What if we drop the await? Well, now at that point, we're getting into what we call a fan-out and fan-in pattern, where you might get the list, for example, this code, where we have function 1 that will return us, still with await, a list of ln for us to execute. And that list is then going to go through the call activity async of F2, and all of those elements of the list are going to be passed to the second functions. But now if you notice, there's no await. So the orchestrator will never yield back. It will just queue up all of those functions. And it doesn't matter how many of them you have, it will just queue them all. But if you go to the highlighted part of the code, where we do task.whenAll, it's basically at that point where we say, we're going to wait for all those queued items to complete execution before we move forward. And all of those activities are going to be starting execution in a parallel mode. And just like in any serverless fashions, things are going to scale depending on the size of your queues. So if your queues reaches high numbers, we will provide more servers to execute those in parallels. And it doesn't matter if you're running all on the same servers or on 25 servers. My record, by the way, is 147. It was fun. I hope the team didn't get paged. It was actually stuck at that point. I think I reached a quota or something. But But when all those tasks have finished executing, then we can do an operation on all the results of all those tasks. And finally, we want to save it. Like, if you remember, initially we have the event, we have the code, but we have the output. This is where we want to save the output. We want to do something with the value we processed. But what about code that would require human interactions? We always have this process where we request approval from somebody, and we want to make sure that that person has looked at that code or looked at that document, and we want to run this process. So what if we require approval from someone, then we can use timeouts to make sure that we have this process done. So let's look at this code, where we're using the current date time. We're saying, like, you know what? You have 3 days to answer this. For 72 hours, right? Yeah, 3 days. Then we're going to create a timer, which is going to be a task, and we're going to wait for an external event. That external event can come from any other triggers. It can come from any other part of your code. It can come from any other functions, any other ways. It can be a document has been uploaded. You know what? It's been approved. And if that approval event is the one that is returned, then we will handle it. We'll cancel the timeout. We'll handle the approval. But if the timeout is reached, we want to escalate the issue. And all of this code, when it waits, it's still serverless, as in we're going to wait for the external event. So the orchestrator is suspended. You're not paying for it. Everything else is not running. You're not paying for it. So you're waiting for up to 3 days for somebody here to do something in a serverless fashion without incurring any cost of an API that stays up all the time just to make sure that maybe somebody's going to answer it. And this is where we get into meme territory. Anybody knows what a meme is? Like, we heard you loved orchestrators. Now we put orchestrators in your orchestrator. Like, that's the kind of stuff we're at right now. So here's a type of code you would find, for example, in IoT devices provisioning scenario, where I would like to get all the list of devices, all the IDs, and I would like to start an orchestrator for all those devices. So each of those devices have their own orchestrators, their own workflow to run on, so they can start doing whatever you want from this workflow. But that orchestrator could be assigned to a completely different team, or those orchestrators could be assembled like Legos to build something greater than the sum of its part. At that point, it's completely up to you and your imagination to, like, what do you want to build with that? But just like Uncle Ben said, with great power comes great responsibility, right? There's a few things to know. So first, language support. We only support C# and Node. If it's the kind of things that you like, you have to talk to me, because I know the PM teams on the Azure Functions, from the Azure Durable Functions team. And if you want a language to be supported, we kind of need customer demand for that. I heard about Python would be nice, and I heard about Java would be nice. So if you have any feedback on this, let me know. I'll put pressure. And next, just like the Genie and Aladdin, there's important details and limitations. Because things look amazing, but you may end up your nose into a wall. So you have to remember that the orchestrator is going to be replayed on every reiteration of the workflow. And the activity functions are not replayed. So what does that mean? It means that if you're doing, that means that your orchestrator code must be deterministic. So there's a whole bunch of stuff you should not do. So you should not write datetime.now. You should not write, for example, sending email in an orchestrator. Because every time he's going to rehydrate, he's going to send an email. And if you're sending it to your boss, he's going to get spammed. You should not be using any I/O or any application call in the orchestrator. We have workaround for all of this. And it's the same for infinite loops. Sometimes you need this process that runs all the time. But if you remember, we have a ledger. And this ledger is per orchestrator. And if that ledger keeps on adding up and adding up and adding up and adding up forever, we need at some point a way to reset the orchestration. So we have ways and workarounds for those kind of things. But basically everything that is logic dependent on time. For example, datetime, or you have API calls and stuff like that. Should either use should use an activity functions, or should use a workaround. So with that in mind, Dribble Functions is basically just an extension. It is open source. We have the code available online. The only thing that Azure Functions actually does not have online for free for all of us to use is what we call the plane for the scaling. So the things that allows us to go from 1 to 100 servers. That's the only thing we don't have open source right now. So Dribble Function is an extension that you can find on GitHub. It runs in user space, so we're not running anything specific on the server. It's not a product. And the three core key components for Dribble Functions are queues for any activity queuing, their table for all input and output in the event sourcing history, and the blob storage for everything that is too large. So if you're passing in a JSON as a parameter, or if you're passing in an object and the serialized content is too big for an Azure table, we're going to put it in a blob. And remember, exception and errors are valid output of a function. So you will have stack trace and everything else in valid output of a function. So if you throw an exception, it will be your output for that specific activity. So yeah, how did I blew it? I tend to break stuff. I'm the kind of guy that will break stuff and will tell you because I don't want you to fall into the same problems. So basically here what I have is a little bit of a code that I was doing. I hate when companies have samples with links that are dead. You're clicking on the links like, yay, that's going to help me out, and boom, dead links. So what I wanted to know was like, what about our samples? We have 1,000 samples. Let's see if all those links still works. So I started hammering our docs and all our different links that we had, and all of our samples and all of the Azure samples org. And basically what I did was do this. So we see here the first two lines, we have the call activity async for the get all links. This is a fan out, fan in pattern that we talked earlier. This one returns a whole bunch of links. And then in the for each, we have resolve link. So what I'm doing, simple HTTP request. Let's do an HTTP request. And if it works, well, it works. And if it fails, well, I'll have an exception and I'll manage them later. And then I do task.whenAll. So anybody knows what happened? So basically, when you get a 500, you can handle. When you get 400, you can handle. Any kind of HTTP code, actually, you can handle. And I handled that in my code. But then I started getting into those very old samples that had links that were on domains that just did not get renewed at all. So I started getting those DNS errors, and those I did not handle. And the amount of links that I had at the beginning was about 10,000. So I queued up about 10,000 links to be queued, which basically made me reach 137 instances on Azure Functions. And then they started throwing those exceptions. Anybody knows like how big an exception like in string format is in C#? Same thing as Java. It's pretty big. And then you have those 10,000, and then you would wait for all of those to complete. But the thing is, every time it throws an exception, it stores it. And every time the orchestrator would restart, we'll try to rehydrate the exceptions and the 10,000 links and the 10,000 exceptions. And yeah, basically I was killing storage. My storage account started like getting very expensive. Not Azure Functions, the actual storage. And the funny part with C# is that await task.whenAll, if there's any task that throw in exceptions, it throws again. So something that should have taken me 2 minutes to run took me 2 hours. And those are a few lessons like that you need to know. You need to handle your exception for those kind of codes. You probably heard that in the previous session about handling errors in the serverless scenarios. And the best way for me to see that going was by using application insights. Because if you're not using anything else, even if it's not application insight, use something. Because you want to know when things start to fall apart. And mine, that is actually 146 servers. That was actually a screenshot from that event. you see here the outgoing requests, the dependency rate call failures. Those look like small bumps, but we're about 100 per second. The first line at bottom is 0, but the next one is 100, and then 200. So I was throwing a massive amount of exceptions. And it took way too long for this to run. But I was able to get some pretty good numbers. So if you want to have a little bit of fun with that code, how much time do we have left? 2 minutes. So I don't have time to run code. I hate that. If you want code, that is actually a photo you want to take. So I provide 2 samples. Those 2 samples are both in C# and in Node. They still work. I update them on the regular, so you don't have to. And if you want to run that on Azure itself, you can run it with a free trial account, no problems. But the thing is, you don't need Azure to run this. You can run this on your local environment, on Windows, on Mac, on wherever you want. But the spec of the samples is very simple. You retrieve the count of open issue for a repository for a determined GitHub organization, and you save them to an Azure table. So basically, I have the Azure samples org, and I want to get all of the amount of open issues for each repositories. This is what the sample does, and it saves them to an Azure table. It could save them anywhere else, doesn't really matter. It could use any other filters. What about open issues that haven't been handled, that haven't had any activities for the past 6 months? Do you hate that when people when you open an issue and nobody ever answers it? What if you could do that scenario for your enterprise? With $0, of course, because it's super simple. Because it's serverless. And just like any other serverless providers, we offer basically a free tier, right? So if you want to try it out, you can try those samples, get them on your machine, try them out. And if you want to complain or you have any other issues, well, you know what? I'm not afraid. Reach me out on Twitter. Send me an email. I will answer. I'm there. So my name has been Maxime Rouiller. Thank you so much for your time, and I hope you have an amazing day in Boston today.